Well, thank you very much, everyone. My name is Sztefan Edwards. I'll be talking about basically the direction I'm going as a programmer who works in InfoSec. And what I do is obviously very different from what most other folks do at this conference. So it might be interesting, it might not be. But basically, this is how I hate everything that I do except for type systems, because they make my life a little bit easier. But as I said, my name is Sztefan Edwards. I work for a great company called Invisium. I'm saying that because they paid me to be here, so I have to say that. But you can basically find me as Logical on GitHub, Twitter, Lobster, etc. But Invisium is great because we do AppSec, we break applications, we find flaws. We're also a really big Scala shop. So one of the things that I liked when I came over was that Jack, our CEO, was a big Scala head, so we could actually talk. I actually didn't really know Scala up until I wrote this talk. So, and we'll get into why. But basically, Invisium is a Scala company, and it's one of the directions that we're going in InfoSec, both from a defensive side as well as an offensive side. Just a warning, I'm actually hard of hearing, so if I ask you to repeat your question like 17 times, it has nothing to do with you, it's me. I lost my hearing as a child, so I have that problem. And also, I'm from New York, so very often if I'm talking really fast, that it might get really awkward because I'm thinking about something else, but you may not actually understand what I'm saying. So if I'm talking too fast or if my accent is too thick, just flag me down. But basically, the too long didn't watch of this talk is that I want to model violence. I want to model what I do as an attacker instead of going through the things that we in InfoSec normally do, wherein we come up with these really hacky, really terrible approaches to breaking software. I wanted to come up with something a little bit more formalized. But the thing is that in InfoSec, especially with what I do, I very rarely have more than 1 week to do what I have to do. So if a customer asks me to come in and do something, I roughly have a week from 9 a.m. on Monday until 1700 on Friday to break that. Doesn't matter what it is, right? So I have to figure out what I'm doing there. And I work with teams of very smart folks, and we work really hard on these sorts of things, but we have a week. Now the week is important because I actually pressed myself to learn and write this entire talk in Scala in a week. So starting on Sunday a week ago, I picked up actually working in Scala, and now I'm here. So we'll see how far we can get into it. And the reason why I want to talk about this is because I write a ton of tools. Most of my job is actually writing tools for myself, my own consumption. So for example, last week I was actually on site at a client, and I was writing protocol fuzzers. They had a bespoke wire protocol written in C, and we were on site to see if we could fuzz that and break anything in it, see how far we could get, right? These are the sorts of projects that I end up doing. I've written static analysis tools whilst on site. Client asked me to find logic bombs, right? What's the easiest way to do that is to scan all the code. So I scanned all the code for date, because they had issues with dates, with a developer leaving at a very specific date and making that very well known. So we've written those sorts of tools. And the last thing I constantly write is documentation generators. And I write pipes of things to awk, to grep, to sed, to rewrite it into Markdown, to spit into our risk management system. So these sorts of things are what I'm constantly writing, and I write them in the most terrible way most of the time. And I really, oh, sure.
Sorry, could you expand on the developer left at a particular date and made it well known? Did he say like, aha, if you note I'm leaving on July the 4th?
Yes, literally.
Okay.
So the client had actually asked us to look at it was something like 2.5 million lines of Python, to actually look at that with the focus of so-and-so is leaving on this date, and this person is core to our development team, and this is an existential threat to us as a business. So figure out what this was. And that was a team of 8 people looking at this Python code, so that had a long cacophonous symphony of failure as well. But basically what I do is adversarial testing, right? So if we wanted to take an adversarial testing as an example, we can use this one. Client calls me on site to do a malicious code review. I come on site, and I walked out with 2.3 gigs of source code from them. I walked out with their red team manual. I walked out with all of their banking information, all of their FTP credentials, all of their internal database credentials, all of their internal hosts, and I stole documentation from the person I was working with. So these are the sorts of things that I do, right? Now the problem is that I have to then explain to them how I got what I did, right? So for that example, when the application booted, it hit a specific server to do something. I didn't know what it was doing. And actually what it was hitting was CVS. If you remember, CVS was a predecessor to SVN, is a source code repository, right? And basically from access to just booting up the application, I was able to grab all of their source code. And they had no network monitoring that would stop me. So that's the sort of thing that I do. I do these sorts of assessments. Now, where it gets adversarial is I don't necessarily know anything about the client. I may know a client name and then have to go find out all the rest of the information that I do. So for example, we may have a client that comes in and says, our domain is, such and such.xyz. Find out everything that you can about us. And then find out a bunch of stuff, run a bunch of tools, part of which I'll display today. And I deliver that information back to the client. So this is my basic workflow, right? I recon anything that I can see in assets. Those can be languages. So for example, a really great thing that I like to do is what your developer postings are. So if you don't want to tell me what languages you use internally, I'll actually look at who you're hiring for and see that you're hiring for Scala developers who happen to have a background in Spring. And then I will focus my exploits against that, for example. So my recon purposes can be anything from all of your hiring practices all the way through to what your network looks like and what your applications look like, what source code I can find from you. And then basically I take that and feed it into the rest of the process. Now what I want to do, and what I've been trying, and what Jack and I and others at Invisium have been working on, is to actually machine this entire workflow. So this is NIST 800-115, if you're familiar with the NIST series. This is the actual workflow that you're supposed to do for technical assessments. So this is the direction that I'm going. At Invisium, we have a slightly different one, but I come from that semi-government background. And when I'm doing, oh, sure.
So how long would you typically be spending on recon, for example? Like what kind of time frame? Are we talking like a month, 2 months? What are we talking?
So it actually depends on what we're doing for that assessment. So if we are doing a small network assessment, it might actually just be a few hours. Because we still, again, only have a week's worth of time, maybe 2 weeks worth of time. So, when a good friend of mine who we worked together, David Corsi, he and I were on an assessment, and client had been hacked, right? Our reconnaissance flow was an hour before we figured out the general direction that you could take to get into their network. Now, that was because it was painfully obvious, right? But, we may only have a handful of hours. Now, we do have longer assessments where we have months to do that sort of thing, but that's very rare, and generally that generates huge amounts of data. So when I'm writing tools, I'm generally on the Unix command line, right? These are tiny tools that I pipe into other tools, and I keep piping and building things up. And they're generally around 100 lines of code, let's say, right? This is to, rip apart an Nmap scan, rip apart some SAST, rip apart something from their application. So this week I decided, and what I was shooting for was to see if I could write some of the similar tools that I do for myself in like Python, C, Ruby, Shell, etc., and come up with the same things in Scala. Because I didn't really know Scala, so I thought it would be an interesting challenge. So this week I wrote a DNS enumerator, a port scanner, a full HTTP stack, a CSRF proof of concept generator. So CSRF is a vulnerability that we'll discuss later on, and a web spider. These are terrible. The quality is not something that I would ever want to push out. Like I wouldn't want other people using these. But the point was to see if I can get the same density of code and the same style from something that I put a modicum of effort into. So let's talk enumeration, right? Very often people put things out on the internet that they shouldn't. That's the entire point, right? So when we're doing these sorts of assessments, we're looking to see what other information they accidentally put out there. So one of the ones that I love to find is test www or origin www. So they'll have something like Akamai or Cloudflare in front of their application, and then they will have accidentally exposed externally their origin server, which does not have the same protections, right? So I can do an end run around their WAF and start to attack that application. So when we're doing DNS enumeration, we're actually brute forcing all of the DNS names that we can find. So we will try www0, www1, www New York, all those sorts of things. And we generally write tools to do this. We have a question, by the way.
Oh, just wanted a clarification on the expression of end-round law.
Uh-huh.
Could you clarify those two terms, end-round law?
Oh, end-run just means go around to avoid it. And a WAF is a web application firewall. So it's a firewall that actually sits at layer 7 on the OSI model, right? So basically it sits and reads HTTP traffic and says, yes, this traffic is good, no, that traffic's bad. So unlike a regular firewall, which sits down at TCP or below, this will actually be up right at the top and will block those sorts of attacks. So when we can end run around them from DNS, it means that we can just literally bypass them and have raw application access, which we shouldn't. Does that answer your question?
Yes.
So I write tools like this. This is actually from an assessment. It's a Python program that reads in a list of prefixes that have been munged together from things I extracted from a client, right? So I extracted some of their names, I mixed in some common DNS names, and then put them together into this Python script. This Python script generates a shell script. The shell script generates another file. That file is then read by C and stuck into SQLite so that the rest of my processes can work with this, which is awful, right? It's a terrible process. It's super broken, but it works. I was able to find a number of hosts that this client had been hiding out there in DNS just by this. This is the sort of stuff that we do to break your applications, to break your systems. It's nothing actually interesting. It's just a bunch of shell commands stringed together. But that's the attack surface that we have. So, as I said, we generate that shell script and stick it out and end up with a full report on that client on everything that we were able to enumerate, just from those. So a bunch of terrible Python and shell expressions together gives us access to things that we shouldn't have access to. Now there's a couple problems with this. It's vulnerability focused instead of security focused. And I make that distinction because security is actually a correctness problem. It's not a problem of finding or playing whack-a-mole with us. So red team should be finding issues, absolutely, but blue team should be designing things. They should not be just patching the vulnerabilities that we find in situ. So very often when you are coming up with when we come up with issues and we provide them back to blue team, they run out and patch those issues, but then we run into situations where we give them an example expression, let's say, and then they literally take that example expression and block that in the application, not the root cause of the problem. So we give them script alert 1 from JavaScript, and they go into their application and block script alert 1. So we end up with these tiny collections of code that have no documentation. I mean, God forbid I have to explain what I did 6 months ago to actually break into something. If I haven't documented that, I'm out of luck. I usually end up just recreating it. Honestly, the tools are like 100 lines. There's no typing information, so very often, like I have a colleague, Brian, he very often does a lot of my peer reviews, and he'll come up and he'll say, hey, this looks great, but you accidentally put the host name 1 column over, and I'll go back and be like, oh yeah, that's right, for that tool I have to actually put it into this other format, there's a sed script I'm missing. It's terrible. And coming up with the actual execution path that we have to have here is atrocious. It's really painful. It's basically me scribbling down in notes outside of the system to see what else we can come up with. So it's...
So I'm wondering, how often do you have some sort of statistics or frequency for how many companies take the patch vulnerabilities path versus those that, oh, we have security issues that we can take care of?
Yes, it is 100% take the patch vulnerability. Okay, 99.9 repeating take the patch approach versus actual design. Design costs money. All of us are very expensive people in this room. Doesn't matter what position you do, right? In order to actually get like a real blue team focused with design and all the PLT nerds and stuff that you want, that costs money, right? Those are cost sinks, right? Security is very often viewed as a cost sink, right? So it's easier to just tell your sysadmin to put a WAF in front of something that I found versus to have, you know, a bunch of actual smart people fix that issue from the design going forward.
As a follow-up, do you get repeated contracts from the same client?
We not only have repeated contracts, but we'll very often just deliver the same report. It will be no different. I mean, it's funny, right? The first time is like, haha. The third time, you just want to drink. I mean, there's really nothing that you want to do. Sure.
And it's not there that you automatize that sort of stuff. I mean, you have some automatic tests that tell you that, oh, this company, already I told them that this server was like last week, and now again they have the same error. I mean, have you thought this idea of automation and of tests? I don't know.
Yeah, sure. So the question is, like, you know, how much of this is us not relaying that information properly to them, and how?
Yeah.
Yeah. So I work with a really great company. Can't say their name, obviously, but we chat on Twitter often. Really great guy, and he and I have talked about this because we've all seen this, right? Security very often goes to management and has to say, hey, we have this issue, right? Now his management is very accepting of that, so he gets very far with that. But when I go to other clients and I go to other customers, they very often can look at something and say, we accept that risk. And it's understandable, right? I may come up with something that is, for me, a problem, right? Hey, look, I can XSS anyone, and I did this path to do so, right? I can do X, Y, and Z and end up with some information that I shouldn't have. But at the end of the day, I can only say what I saw in the application. I can't take a business-sensitive, contextualized output and actually render what the problem is in light of their expenses. These are businesses, right? So they may have vulnerabilities that are there, but that it's not worth it for them to fix at this time. Or they may have something that they want to fix, 6 months from now. They're doing a new release. They don't want to fix it now. So it can be very difficult to get into. So.
I have a question.
Absolutely.
So how often is the case that you tell a company that they're using an updated version of some module in their web application, but they say, no, we won't update it, and then you do again a report in 2 years and you say, okay, this XSS vulnerabilities is still there. So how often is that happening? All the time.
It's super frequent. We have customers that are, everyone familiar with struts?
Exactly.
Yeah, so we actually have customers that are still running ancient versions of Struts 1. So not even like late versions of Struts 1, ancient. Sure.
Not familiar.
Oh, so Struts is a Java library for basically wiring up models to views and things like that. And it has a number of flaws, especially in Struts 1. And my previous company, this company, we have clients that will stick to Struts 1 because they're not going to update that application. So yes, frequently, all the time. So basically, when I'm talking with customers, very often I talk about types and shapes and models and correctness and all those sorts of things. So I thought, why don't I start to apply that to my side rather than to just their side? And this is the reason why. So does everyone know what the ETag header is? So ETag is a header on HTTP responses that tells you that the content is of a specific size, and you basically, when you issue an HTTP request, you can include this ETag header to say, hey, have I seen this piece of content before, yes or no? And the server can read that ETag back and say, yes, you have, and then not actually deliver the rest of the content, right? So the problem is that e-tags can be used for all sorts of things, such as enumerating the number of hosts in a cluster. That's what I usually use it for. And I have a tool called Lovitz, which basically reads in output from other tools and spits out a report for me. And this is what I ended up doing for a client to find all the servers that I could that had e-tag vulnerabilities, so that I could enumerate all the hosts that they had in their entire cluster, was this. And it's terrible. If you didn't know what this was, like if I tried to hand this off to one of my colleagues, they would throw their hands up. And trying to pass it out now would be problematic as well. So I'm trying to get away from this. So functional programming is very well known for design. It's very well known for thinking, coming up with very small, impactful changes, right? But I wanted to see if I could get the same code density as I'm getting with Python, with C, with Shell, etc., in FP with types that are better than being stringly typed like I do right now, right? So I was trying to see if, in a week, without really thinking about it, if I could come up with types and methods and functions that would work. So I gave myself about a week. I started on Sunday of last week, and I learned Scala. I have a background in OCaml and Scheme and F# and things like that, so it wasn't a huge stretch for me. But I just really wanted to see how far into it we could actually get, right? So I did it, roughly. I was pretty happy with it. There were a few pain points along the way, but it was mostly me mashing at the keyboard to come up with things. But basically, I wrote about 700 lines of Scala in this week to do my workflow with documentation and to actually go from DNS all the way through to web exploitation. And the types are terrible. I was working on it last night a little bit, and I realized that there were several refactors I could do. But the nice thing about it is I can refactor without having to pull my hair out the entire time whilst trying to figure out why this thing is over here now all of a sudden. So I want to go from these hacky processes, these unclean, very, very, very difficult processes that I have been doing, and head towards an actual modeled, understood chain of attacks that I can demo to a client. And this is what I'm going for, right? We have some sort of process that we have, like NIST 800-115. NIST 861 is for incident responders, right? NIST 860 is also in that process. Or the OWASP top 10. Anyone familiar with what OWASP is? Okay, we have a few hands. That's a little more common than the other things that I've been talking about. Basically, the top 10 is a list of vulnerabilities that OWASP feels should be, displayed. There's some political commentary there that I won't get into. But basically, I want to have simple processes that I can pipe into one another and come up with typed issues and typed results that I can then provide to a client afterwards. Instead of a bunch of strings and a bunch of data output and a bunch of terribleness, I can then provide them actual typed examples, and I can extract information from these. And sure. I cannot hear you whatsoever. I'm sorry. Oh, there you go.
The types on line 3, they looks like OCaml?
Yeah, so I originally was going to do the talk in OCaml, and then I was like, no, I'll do this in Scala. That will be more fun. But basically, I wanted to see if I could, and that's also why there's a pipe angle bracket there as well. I missed that a lot this week whilst programming in Scala. But basically, I wanted to get down to this level where I could have similar processes to what we have, but I could also come up with, I could come up with something that is better than what I did. Sure.
So what you're doing is basically the old Unix-style pipeline composition, only with actual typed data rather than a list of strings and so on.
Yeah, correct, exactly. And this is not an interesting talk. I mean, there's no interesting data that's coming out of this. I didn't even have to use monads for most of what I was doing. I don't have to explain semi-groups to my coworkers. I don't have to do anything. I can literally just give them a list of type definitions and a bunch of functions, and it worked. And that's what I was aiming for, right? We could all go to a really theoretical place with this. We could come up with some really awesome model for security, and I could relay all that information and be really awesome, but it wouldn't be necessarily useful for like providing out into the wider scheme for us as InfoSec. Yes?
So the reason why you use Scala was that your coworkers are already familiar with the language?
So we use Scala heavily internally. We actually have we're working on a new platform that's based off of Scala. But internally, actually, our pipeline, we have a bunch of Python folks, we have a bunch of Go folks, we have Scala, we have Ruby, including one very vocal Rubyist. But we basically have a bunch of languages that we use. I write stuff in whatever I feel like. My coworkers hate me, but you know, I provide whatever I can. So yes.
So do you think the inherent slower development cycle or development feedback will slow you down, unlike just hacking something in shell?
I only heard the first part of your question.
So in Scala, you're going to have an inherent slower development feedback or loop, development loop. Do you think that's going to slow it down, unlike just hacking something in shell?
So the question is like, is Scala and those types of things inherently slower? Is that about right?
In terms of development cycle.
In terms of development cycle, yes, absolutely. So I wrote about 700 lines of Scala this week with types that flowed basically from, you could flow from DNS to network scans to HTTP exploits. So from my perspective, I didn't find it that much slower. In fact, I've caught bugs in my own logic that I normally would have to like catch afterwards when I'm reporting, and Brian yells at me or Dave Corsi yells at me because my reports are messed up. So it was actually kind of neat to catch that stuff ahead of time, because this is like the epiphany moment that I try to sell on to customers to. So that was literally what I was aiming for, to see if it was slower and whatnot, and I don't really think it was. Now I come from an FP background, right? I've been programming in Scheme since I was 15, so what is that, 17 years, right? I have my own Scheme system. I've delivered Scheme to clients, right? So, I have that background, obviously, so ramp up there would be interesting. But I don't think it would be any worse than, say, picking up Rust or picking up any other like heavily typed language that we're heading towards in InfoSec anyway. So.
What about following changes?
What about what?
Following changes, like you have something
Following changes.
I'm sorry?
I can't speak up.
Yeah, because I can't hear at all.
All right, can you hear me?
Yes, that's
What about
perfect.
following up changes? So you have something already built,
Mm-hmm.
say it in shell, you're in your terminal, you run it, you need to make a change, you just do it, like hack it and run it. What
Yeah.
about Scala? You need to compile things, right?
Well,
That was more the original question.
yeah,
That's
so
it.
in Scala, I'm trying, I was trying to make sure that the types make me be better, to make me pipeline things the way that I expected them to. And if I couldn't pipeline them the way that I was expecting them to, I changed them. So that cycle of feedback was much nicer for me. Whereas in shell, if you're familiar with shell, I will very often be like, bang 512 to rerun that command again, or load up the previous command with caret, rewrite something else. I don't know how much Unix people actually want to use here, but basically I end up rewriting a bunch of shell commands very terribly. Or you'll go into my output directory and they'll be like fuzz 0, fuzz 1, new fuzz, you just hack it and get it done. Whereas I was trying to avoid those sorts of situations here.
Are you still shelling out, or are you using my built-in list to do the stuff?
So funny that you asked that. I wanted to implement it in pure Scala. So there is a pure Scala TCP Connect scanning engine in here. There is a pure Scala HTTP client, all that jazz. But the interesting thing that I was thinking about is that there would be no difference between shelling out or, if you actually implemented the types properly and implemented the processes properly, there'd be no difference between those two, because you could extract the same information from both and type them and then provide the same pipeline afterwards, which is what I was aiming for. So, as I said, I wrote these things. What do we have? We're roughly about 10 minutes. So let's actually just skip. So this is part of what I was writing, and in fact, your question comes up right here. I was thinking about this as well because I wanted to know. I very often use dig It's a Unix command line tool for querying DNS servers. So for example, I might be on site, I see something has a DNS server, and I'd be like, oh, that's interesting. What information do you hold for me? So you having dig there would be very interesting. But I also wanted to have an internal one that I didn't have to rely on dig itself as well. So the neat thing that I saw coming out of this was that I could come up with the same processes for both and not have to do any other separate processing there, and still have the type system enforce me so that I know that my pipeline is working as I expected it to. So this is basically my entire process for it. Obviously, implementation is left undefined, but you can basically come in and read and understand what I'm attempting to do here. I'm attempting to generate a bunch of names and then query them. That's it, nothing complicated. Right? And what I thought was really interesting about this was that my attacks can then start to equal my models or be congruent to my models mod some sort of harm. Right? So for example, very often clients will say to me, but what HTTP request was the one that actually caused that issue? And I'll look at them and say, I have no idea. Here's a bunch of them. Try these. It's one of these guys, I know it. So what I can do now is I can actually start to collect those sort of processes together, and instead of giving them a bunch of Python scripts or instead of giving them requests that we think work, we can actually give them an entire typed flow and extract that. And again, we can come up with one set of documentation tools, one set of processing tools that are simple and composable that we can actually spit out and receive that same information. Now I'm rushing a bit because I actually wanted to play a game with you. So has anyone heard of a capture the flag before? Great. So capture the flag is basically someone has designed an intentionally vulnerable service, right? So there's one running on r.logical.com. So the point here is to do some service discovery, figure out where that's running. If you want to play, you shouldn't watch the rest of the talk. Figure out that service discovery, and then parlay the other vulnerabilities here to actually steal a cookie. So there is same site request forgery on that app. So same site request forgery basically means that you can trick the app into issuing a post request, or any request really, but post in this case, a post request to the server itself, right? But you can't do it cross-site. So you can't spin up your own site, have a victim view that, and then have a request go there. There's self-XSS, which means that you can actually XSS yourself, but you cannot actually XSS anyone else. And then there's a cookie without, a session cookie without HTTP only set on it. Does anyone know what HTTP only is? Okay. HTTP only means that a browser does not expose that cookie to JavaScript. So basically, an attacker has to do other things to capture that cookie. So there's a game here if you want to play it. You can try, see if you can come up with a model for how to exploit this, right? What I did was this. I queried, found a bunch of hosts, ran the internal port scanner against it, since I didn't want to run nmat against it, found that the service was running on port 8080, right? So there was a bunch of other hosts that we scanned, or a bunch of other ports that we scanned that weren't open. And so I'm curious as to what 8080 is, because that's always fun, right? Nothing unfun ever runs on 8080. And I generated this. Now, obviously, I did a bunch of like, oh, you know, HTTP get my target, blah, 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 right? And go through and expose what those are. But the basic proof of concept here is this. I came up with these. These are my targets out of that list of scans. And these are the two requests that I needed to do to basically test where I was. So as you can see, I have a response of 303, see other, and it's telling me go log in. So here is the actual exploit. I did not put the payload in here though, so if you're actually curious, don't read the GitHub repository, which I will open after this. But this is my model. Now what's actually interesting about this is, barring cookies, if I provided this to a client, I could also extract the HTTP requests out of this. So not only do I have the information that I provided, that this was the order in which things were done, I also have the actual HTTP requests themselves. I don't have to then look through any burp history or anything of this way. I can start to extract models of what the type flow was, of what the attack flow was, and to actually come up with it. Now, as to whether or not this was slower or not, a lot of these sums afterwards, I was like, oh, clearly I should have just used something else because I can, this is really annoying to have to say sum for all of these. But I could also extract those with methods. I could make things higher level, or I could just come up with a different model. But it worked pretty well for me. I found it pretty interesting. Oh, I did put the payload in here. Ha, lied. So this was the actual payload that I had come up with. This is the SSRF itself. You cause you put in a form that causes the search system to actually XSS you after you interact with the search system itself, or interact with the survey system itself. And this is the actual resulting payload. So we went from DNS, trying to find service, to scanning this, to looking for this, and coming up with these two. These are the actual things that are problematic. Now, normally me as a red teamer, this is what I provide. This is what I would tell you. I'd be like, I did that form and it did this thing and now you're broke. And that's it. But what I'm looking for is to actually be able to provide them more useful information where they can start to see the flow, they can start to see the types, they can start to see that, those sorts of attacks as they went through the application itself. So, future directions. I'd really like to do architecture this way. So I do a lot of what are called security architecture reviews. So a client comes in and is like, hey, this is my AWS system. What do you think? And I'll be like, it's broken. But I'd really love to be able to point out and parse, like, let's say, parse some of their definitions, right? Parse vagrant, parse anything that they have there, come up with a model and then compare it to what they're actually doing in their architecture diagram. So that code then becomes your ARD or your architecture diagram, and that we can actually start to assign types to data flows. So for example, if you have a backend connection that is a database connection, you're not using TLS on that, we can actually flag that itself. And then in Visium, as I had mentioned, we ourselves are moving towards an actual service pipeline where we're moving towards hybrid testing. So rather than a lot of the manual things that we necessarily do, a lot of these things will actually be run in a service. And we use Scala and Akka and all sorts of cool stuff to do that, so that you have a sort of like expert system. Remember expert systems? Anyone? No? Okay, so we have a sort of like knowledge base that continuously feeds back into what you're doing, as well as what the system itself understands and knows about. Oh no, did I not? I didn't even expect to make it this far, so I didn't even have a questions and thank you slide. But so thank you very much, everyone. Does anyone have any closing questions or anything before we go? Can you get a mic though so I can hear you? I apologize, it's just I don't want you to repeat yourself 7 times, and then I'll still look around the room.
Yeah, thank you for this. It was really, yeah.
It's a lot of information. Yeah. I understand that I'm like spraying you all with a fire hose here, but...
So do you do any work with government agencies at all?
I used to. I no longer work in government.
Okay. I read recently about how they tend to focus a lot more on attacking rather than designing for security.
Government?
Yeah.
So I would honestly say that here's the thing. Government is they have very heavy design processes. They have a lot of these safety procedures in place. So you can come up against one of the best design systems, but you can also come up against one of the best design flaws as well, if that makes sense. So they don't focus on attacking per se, unless you work in intelligence community types of stuff. They do a lot of design, but it can be some of the most amazing design, and it can also be like, oh, here is 17 million lines of rational rows. You remember rational rows, right? Right? No, I was 5 when rational rows came out. I don't know rational rows, but okay. So, but anyway, I'm sorry. You had yeah.
I just wanted to get your thoughts on that kind of process. Okay.
I mean, government has some of the best attackers out there. Absolutely. They also pay a lot of money for exploits. So if anyone has an exploit, you can sell it to, you know, any of those great shadowy brokers. But, you know, they also do focus quite a bit on design. It's just if that design is effective or not. So, which in my case, I have largely seen it be effective. There would be layers of controls. So for example, it took me like 3 days to be able to plug into the network to test something that had no vulnerabilities. And I had 2 weeks to do that. So it was like 2 weeks of throwing everything I can think of at this application. Where, by the way, in order to get to this application, you have to bypass all the dudes with guns outside and then get into the building, which has like, you know, cards. And then once you get past those things, then you can also plug in maybe to the network, maybe. So, you know, yes, it's layers of design.
All right, thanks.
Another question? Of course.
Just a quick one.
I think there's one in back, and then we'll get you.
Hi. What usually happens when they stop you walking inside a building?
What should happen?
Yeah, what usually happens? Because you don't belong there.
Usually it's not the security guard, like if I'm doing a physical test or something. So honestly, usually physical tests for me are because I made it into a physical test because you made me came on site, so why not? It's usually been me exposing myself to the actual security point of contact and being like, hey, by the way, this is a selfie of me with your servers. Or calling and being like, hey, by the way, that closet that includes all that classified telecommunications equipment, that's actually unlocked, and I'm standing in it right now. So it's usually that. It's usually self-exposure. I've been caught a few times. It's usually by like secretaries. Someone who's like, wait a minute, I've never seen you here before. What are you doing here? And it's like, I just walked in. In Visium ourselves, we mostly do, most of our physical stuff is outsourced to a company called Laris, which a good friend of mine works there, Dan Amadio, and it's super interesting to always hear his discussions, because he's actually paid to do this. I just make my job because I'm that guy. But it's super interesting to hear what he's talking about when he gets into those sorts of things. Did you have one question as well? Oh, okay, sure.
So let's use the coffee break, but for the questions offline, and let's thank Stefan again for his amazing talk.
Perfect. Thank you very much. Is a Scala company, and it's one of the directions that we're going in InfoSec, both from a defensive side as well as an offensive side. Just a warning, I'm actually hard of hearing, so if I ask you to repeat your question like 17 times, it has nothing to do with you, it's me. I lost my hearing as a child, so I have that problem. And also, I'm from New York, so very often if I'm talking really fast, that it might get really awkward, because, you know, I'm thinking about something else, but, you know, you may not actually understand what I'm saying. So if I'm talking too fast or if my accent is too thick, just flag me down. But basically, the too long didn't watch of this talk is that I want to model violence. I want to model what I do as an attacker instead of going through the things that we in InfoSec normally do, wherein we come up with these really hacky, really terrible approaches to breaking software. I wanted to come up with something a little bit more formalized. But the thing is that in InfoSec, especially with what I do, I very rarely have more than 1 week to do what I have to do. So if a customer asks me to come in and do something, I roughly have so I scanned all the code for date, because they had issues with dates, with a developer leaving at a very specific date and making that very well known. So we've written those sorts of tools. And the last thing I constantly write is documentation generators. And I write pipes of things to awk, to grep, to sed, to rewrite it into Markdown, to spit into our risk management system. So these sorts of things are what I'm constantly writing, and I write them in the most terrible way most of the time. And I really, oh, sure.
Sorry, can you expand on the developer left at a particular date and made it well known? Did he say like, aha, you know I'm leaving on July the 4th?
Yes, literally.
Okay.
So the client had actually asked us to look at it was something like 2.5 million lines of Python, to actually look at that with the focus of so-and-so is leaving on this date, and this person is core to our development team, and this is an existential threat to us as a business. So figure out what this was. And that was a team of 8 people looking at this Python code. So, which that had a long cacophonous symphony of failure as well. But basically what I do is adversarial testing, right? So if we wanted to take an adversarial testing as an example, we can use this one. Client calls me on site to do a malicious code review. I come on site and I walked out with 2.3 gigs of source code from them. I walked out with their red team manual. I walked out with all of their banking information, all of their FTP credentials, all of their internal database credentials, all of their internal hosts, and I stole documentation from the person I was working with. So these are the sorts of things that I do, right? Now the problem is that I have to then explain to them how I got what I did, right? So for that example, when the application booted, it hit a specific server to do something. I didn't know what it was doing. And actually what it was hitting was CVS. If you remember, CVS was a predecessor to SVN, is a source code repository, right? And basically from access to just booting up the application, I was able to grab all of their sort of week from 9 a.m. on Monday until 1700 on Friday to break that. Doesn't matter what it is, right? So I have to figure out what I'm doing there. And I work with teams of very smart folks, and we work really hard on these sorts of things, but we have a week. Now the week is important because I actually pressed myself to learn and write this entire talk in Scala in a week. So starting on Sunday a week ago, I picked up actually working in Scala, and now I'm here. So we'll see how far we can get into it. And the reason why I want to talk about this is because I write a ton of tools. Most of my job is actually writing tools for myself, my own consumption. So for example, last week I was actually on site at a client and I was writing protocol fuzzers. They had a bespoke wire protocol written in C, and we were on site to see if we could fuzz that and break anything in it, see how far we could get, right? These are the sorts of projects that I end up doing. I've written static analysis tools whilst on site. Client asked me to find logic bombs, right? What's the easiest way to do that is to scan all the code. Well, thank you very much, everyone. My name is Sztefan Edwards. I'll be talking about basically the direction I'm going as a programmer who works in InfoSec. And what I do is obviously very different from what most other folks do at this conference. So it might be interesting, might not be. But basically, this is how I hate everything that I do except for type systems, because they make my life a little bit easier. But as I said, my name is Sztefan Edwards. I work for a great company called Invisium. I'm saying that because they paid me to be here, so I have to say that. But you can basically find me as Logical on GitHub, Twitter, Lobster, etc. But Invisium is great because we do AppSec, we break applications, we find flaws. We're also a really big Scala shop. So one of the things that I liked when I came over was that Jack, our CEO, was a big Scala head, so we could actually talk. I actually didn't really know Scala up until I wrote this talk. So, and we'll get into why. But basically, Invisium is